Thank you so much, everyone, for joining another episode of the Graph Builders Office Hours. Really excited today. We were supposed to have Sebastian on to talk about Substreams JS, but unfortunately, he was not feeling well. So we are going to have Derek come on from Data Nexus, who's last minute wanted to come on, and that's super great. We're really blessed for that to talk about GraphNode and also to talk about some optimizations for subgraphs. So yeah, excited. And with the further ado, Derek, why don't you go ahead and take it over and take it away.
Okay, perfect. Hello, everyone. I think I recognize most people on this call. So we'll chat about some of the upcoming features that we're going to see in GraphNode 33, which I'm particularly excited about. And then, which that won't take up our full time. After that, I wanted to go over some optimization items. Mac and I will sometimes get pulled into calls with various subgraph developers, and we see these little things that can probably be tweaked. And so if you're thinking with these items, then it will just help as you're building. One thing that I am curious about, though, is whether or not you guys are more interested in optimizing your sync speeds, or if you're more interested in optimizing query latency, because those two get to be pretty different. If we have time, we might be able to go into both of those, but let me know in the chat, and then I'll cater today's talk based off of what is most needed and wanted by you. Yeah, gotta go fast. Okay, cool. So let's look at some of the things coming with GraphNode 33. It looks like this release is expected in order of magnitude, roughly weeks, not quite days. It still has to go through a council vote, and there's a few other points, but we should see this one coming soon. So let's dive into it. So one of the first things that we'll see in the release note is that we will now be supporting Arweave file data sources on the mainnet. The builders DAO put together an example. If anyone's building on or storing NFT metadata or anything on Arweave, you can use that as an example as you're building to start accessing that data. It does already sync inside the studio, but with the release of this, you can then start to deploy that to the decentralized network and leverage the competitive indexing network. Make the screen a little bit bigger. Yeah, let's see. How's that? Wonderful. Okay, good. So Arweave file data sources, and this works very similarly to IPFS file data sources. But now, obviously, we get to access Arweave as our data source. So that one's going to be really exciting. There's a lot of people that are storing NFT metadata on Arweave, as well as other metadata like in Lens protocol. All of the posts, all the interactions that aren't necessarily happening on chain get stored in Arweave. So it'll be great to include this into the network. There's a performance boost for substreams-based subgraphs. This is a little bit general, so I don't know exactly how much of the boost will be, but looking forward to playing around with that one. But we'll get into some of the ones that I'm most excited about. So we've got 3 handlers when we're building subgraphs. We've got our event handlers, which we're all probably pretty familiar with. Call handlers, which we probably try to avoid as much as possible, and then block handlers, which is like oftentimes it's this do not touch thing, because it just destroys your sync speed. But frequently what we found is that, or at least what I've experienced with some of the consumers that we work with, is that if they aren't the source of truth especially for like token prices, if you ever want to get an accurate TVL, you can update token prices as events are being emitted and then recalculate your TVL. But if you want to have a more live stream of what your TVL is and accounting for the token prices being locked inside your contracts, having a block handler was one of the best ways to do that. But you typically don't want to run that every single block. So typically what we were seeing is that people would write inside their block handler logic, trying to figure out or to only run the logic every 500th block or every 100th block, right? So you use a modulus and you see, okay, is this, block, is the block number a 500th block number? If so, go ahead and run the logic. The difficulty with that is that you're still running that handler every single block. So with this new polling block handler, you can now state specific intervals that you want the handler to actually fire. So if you only want it 500 blocks, presumably we should now be able to still scan a range of blocks up to 500. And then at the end of scanning that for your events or whatever else you're indexing, you can then move to firing the actual block handler. So I'm very excited to do some speed tests with this one because we've run into a lot of people that they might want something that just runs on a daily basis, or they might want something that runs a couple of times a day, and so then they can set their polling block handler to every 5,000 blocks or whatever the math on that would look like, and that should help key performance. Runs out, yeah, exactly. So very, very excited to utilize this one. If you guys have any other specific use cases that you're excited about, let me know, because I'm always interested in seeing what nifty things people are building. And the next one, not totally dissimilar, but kind of in the same or a similar stream, is the initialization handlers. So sometimes when you deploy a subgraph, you want to be able to hydrate the store or preload some known information that isn't necessarily gathered. It's not gathered on chain. And with an initialization handler, you can hard code certain values or put some information into the store upon the subgraph first starting. So this could be things as simple as Mac includes a repo for some of the new handlers. Beautiful. But yeah, certain things that you want to be able to load right off the bat, you can include in this, and that should help save some indexing time. Yeah, I'm very excited to start playing around with this one, especially for certain helper entities. We can just go ahead and create those, and yeah, we'll see. And then lastly, adding the data source context in the manifest, which I haven't personally played around with this one too much, but I have talked to some people who are interested in utilizing this feature. Mostly useful for when you're creating templates and you want to be able to see, where was the data source coming from? You can add certain keys into that data source and reference those later inside your mappings. So I have a feeling that we'll be able to do all kinds of tricky things with this one, but so we'll see what fun things we can come up with on that one. So those are the primary updates that I wanted to go over. I think these two are just going to change a lot of the ways that I have built things. I'll give you one example with this polling block handler too. There is a protocol that I built something for where they needed TVL values, but they only really cared about current TVL. They didn't really care about historical TVL. And so we tried to add a block handler in order to sync their information. And then once it got to the chain head and it was synced, they would have a perpetually accurate TVL. But as soon as you add the block handler, it reduces the scanning range that the indexer is able to access. And so, it went from, I think, a range of like 2,000 blocks down to like 100 blocks. So pretty soon it just had god-awful sync speeds. So we templated, or we created a template, and that template included a block handler. And then we would just look for one of the most recent events on chain and initialize that template, near the chain head. That way the first 98% was a really rapid sync, and then the last 2% got to be a little bit painful. But that was a lot better than 100% of it being painful. So So there you go. So those are some of the updates that I'm really excited for. Again, these things can be utilized inside the studio, and to my knowledge, on the hosted service as well. So if you guys have a chance to play around with those, definitely let me know. Okay, good. And then I'm just going to be pulling up Postgres. So Max said in the chat, sync speed. Do we have consensus around that one? Let's dive into it. We got oodles of time. Okay, good. So I wanted to look a little bit under the hood on how we're actually storing information, because this will ultimately be really useful, as you're building, to understand how does this information actually get stored inside the database. I'm going to pull up Postgres here, and I'm just using pgadmin, currently connecting to our indexer. And we'll go to long list of schemas, and I grabbed a really beefy subgraph. If anyone's seen the EIP 721 subgraph, this one's massive. It indexes all of the different 721 records, or 721 NFTs on the mainnet, but it also includes just a ton of extra information. Maybe we need it, maybe we don't need it, but let's take a look. So one of the first misconceptions that I see very frequently is this concept of archival records, right? Which the graph stores archival records. So what does that mean? It's not just that we have access to the total chain, but we have access to every version of every entity that's ever been synced, right? Unless the indexer is pruning their database. And this is kind of the key column to look at as you're considering this. This is a range data type. And so you can see it's called block range, and we have a first number, and then it's either empty or we have a second number. And what this means is this first number is where the entity was first created. And that second number is where some type of a change occurred and that entity is no longer relevant, or it's no longer part of what we would consider to be our current state. So we can see that this is a current state record. And on this entity, right, we're just looking at 721 tokens right now. So this is probably the collection address and maybe the token identifier. Yeah, we've got the contract and then the token identifier. That's probably where that is. Now, anytime we change any of the data points inside this record, we're going to have to end it and then insert a new record for this ID, right? So IDs in this case are not unique. We have a version ID right here, the ID, which that is unique. And so for any of you database people, that's where we're storing our primary key, is on the version ID. But we'll have multiple instances of this entity ID because we store all the iterations of that entity. Okay, good. So that was a crap ton of data. Let's look at what that actually means. Every time we're taking this one NFT and we're changing the owner of that NFT, we're creating another record, right? If you think about this on some of the things that you're building, every time you store a token, you change the token price by just a little bit, you're inserting another record. You end the old, create the new. This table in total, I'm not going to run this right now because it took a long time to run when I was doing it last night. But this table has 200 million records inside of it, right? It gets to be kind of painful to query. So this specific point is going to affect both syncing speeds, but also affect query speed. Yeah, just 200 million, not too bad. But check this out. Only 135 million of them are active state, right? That the difference there, the other 674 million-ish, that's all prior state. So NFTs that got transferred, it has a new owner, and then it stores the prior state record of the previous owner, right? So this is useful because sometimes inside of our queries, let's just go back. Let's go over to a subgraph. Some people know that we can do things like this, but let's just look at if we were to query the database. Let's say that you just want ID, something, right? We'll grab just a single block. This might not be the best example for this one. Let me find a different one that has something a little bit more fun. All right, so we go to the playground. Let's grab a specific token. I think we have price data in here. Volume USD, derived ETH, that works for me. All right, so we grab a specific record. Here we go. Good, so here's a token. Let's just utilize that singular token ID, and we'll take derived ETH, right? So when we're querying this, we're querying current state, right? This is what the derived ETH is right now. Now you can create a time series where you have token day data, so you can get the exact price at the end of a specific day, and you have access to that. But inside the database, we're storing archival records, and you can access all of that by specifying a specific block number. So maybe we want to know the token price as of 1,000 blocks ago. So we can say block number equals that. And we'll see this value just changed. So now we're looking back in time and looking at Postgres. What we're doing is we're querying an entity where the block range has ended, but that stated number that we just input is between these two values. So it says, okay, as of that specific block, this is the state that was true. And so you can get historical information that way. Sometimes historical information's desirable. Sometimes it doesn't matter, right? So these are all things to just kind of consider in the context of whatever you're working on. So, okay, good. That's just some of the foundational levels of inside the database. Now, one of the reasons which Mac mentioned sync speed, so I wanted to kind of go into this one. So I just grabbed a record, singular record, so that we can look at one NFT and its history, right? This one has a ton of transfers, and you can see this table is like kind of tough to query. Yeah, this table is so painful, it just completely shut down my machine. Not active.
You're back. All right, cool.
Yeah, I am back. Can you guys see my screen okay?
Yeah.
Okay, awesome. Okay, yeah. So let's look at this one single entity that we're storing inside the database. And then you can see we have our present state record, and then we have all the different historical versions of that single entity. Okay, good. So why is this important, right? When you're designing your schema, if you have certain records that don't have changing values, you won't have multiple instances of that single record, which is going to make it easier to fetch, right? And in everyone's mappings, at some point, you're going to run, you're going to have a variable where you tried to load an entity from the store. If you have less versions of that same entity, it's going to load a little bit quicker. Not that that's going to be your primary source of sync speed increases, but this is just helpful context so that we can, start building additional things from here. But just to show you, for this NFT, we can see that each time we have this owner changing, we're creating a new entity. But we also have to restore the contract address, restore the ID, right? Restore everything that exists inside this single record in order to create this new entity, including, and this is what I wanted to highlight, the URI, which luckily this isn't, a particularly long URI, but with NFTs, I feel like that's, the cowboy industry of blockchain. sometimes people, just toss in a bunch of JSON, they toss whatever they want in here, right? And so this field can get pretty long, and you're essentially storing that same field multiple times. So just kind of think with that, like if you have a particularly long string, or if you have some type of a manual array, try to avoid creating multiple versions of that same entity, right? As much as you can. Obviously, don't feel like you have to avoid this entirely, but just think with like, okay, is there a better way that I can store this information? Ultimately, your indexers will thank you, and your queries will end up being faster. So this was some data to think with. Does this all make sense? Kind of high level. I can get a thumbs up if it's jiving. If I need to slow down a little bit, just let me know. Bueno. Okay, good. The other thing that I wanted to touch on, just at a database level, just because that's more my background. So databases, like, that's my jam. If you ever ask me to build a front end for you, it's going to look terrible, because that's not my specialty. But another part that's just worth knowing when you're interacting with the graph to index your information is that by default it's going to create a table index on or a column index on each of these columns, right? Which is very useful for when it comes time to query these different fields. I know that we use the term indexing inside the graph, like we index things, but the database definition of index is a little bit different in terms of what purpose that serves. I can go into that a little bit if that's interesting, or if people aren't familiar with what a column index would be. But I'll show you guys. So just because we're already querying the 721 token level, we'll look and we'll see what indexes are created. And by default, you have one index on every column. So we've got token contract, identifier, owner, approval, URI, right? Each of our columns. In addition to that, we have a couple other indexes that are worth noting, specifically the token ID block range excluded. And this is going to index the block range, which again, that's how we said, are we looking at current state or prior state? And it's going to include the ID. So when you're loading from the store, you're passing in an ID. This is the index that's going to get utilized. It takes that ID, looks for the most recent version of that entity, and it's going to return that into your mapping. At Data Nexus, we've played around with like adding some custom indexes. We haven't found too much of a performance boost, because right now GraphNode by default is over indexing as opposed to under indexing. So there you go. Right. I don't know that we need to worry too much about the indexer side, because this is more the builder side. So this is just a view to kind of look at some of the things that go inside of your database, but ultimately it's going to affect you tremendously when it comes time to query this. But also these things will affect your write speeds to the database. So one quick example that I want to show, get that prior query back up. This was a query that someone was running, and it was taking excessively long, and Crab.eth, love that guy. It was taking excessively long, but it was really just kind of poor query design. But you might not necessarily see that, right? Initially, it looks like we're just trying to pull one record from the database, right? We just want one record. We want to know the number of the block and its timestamp. We're trying to see where that time was less than this Unix timestamp, which I want to say that's about a year and a half ago, give or take. So they're filtering it by timestamp, and then we're going to order it by the block number. So what is this going to do at the database level? Okay. Can everyone hear me?
Yep, can hear you now. Welcome back.
You guys, I'm actually super impressed with the fact that I was able to build not one but two queries that broke my machine. And it's pretty impressive. Good experience for us. Okay, cool. So now that we see a little bit of what's wrong with this query, let's look at how to fix it, right? So in some situations, you want to filter things and order things. If you order it by the same thing that you're filtering it by, you can dramatically improve performance. Let's just say, let's order it by timestamp, right? Which timestamp and block numbers, those two have parity, right? As timestamp or as block numbers increase, the timestamp increases. So just by changing that one thing, we can rerun the query and we get instantaneous result. And that's because we are now able to utilize one index at the database level rather than utilizing both, utilizing two and trying to make them play nicely together. And this is especially noticeable. I chose Arbitrum 1 blocks, just because this, it's going to have millions of records inside here. On a table that only has thousands or tens of thousands or even hundreds of thousands of records, you may not run into performance issues. But this was just a good example to see if you can order your queries by the same thing you're filtering it by, and it will dramatically improve your life. That's that one. Okay, good. And then as Mac had requested, just going into some sync speed optimizations. So Simone released an article talking about minimizing the amount of ETH calls that you make inside your mappings. I can't stress that one enough, especially on high volume subgraphs or subgraphs that are indexing a ton of events. Adding those ETH calls, can add, it's a fraction of a second, right? But ultimately, if you're indexing just a ton of events, that can add up real quickly. So if there's ways to deterministically reproduce the same results that your ETH calls are providing, I can't recommend that one enough. And similarly, okay, this one wasn't while running a query, so it must be my my connection. So I'll have to resolve that one. But those are the primary things that I wanted to share on my screen. So I'm going to stop screen sharing, which should hopefully help me from this point forward. Okay, perfect. And yeah, so I guess are there any questions that of things that people are running into, or any specific long syncs, long queries, right? Anything like that? All right. Well, based off of the chat, it doesn't sound like we have any questions. Yeah. So as you guys are building, if you do run into scenarios where you're trying to query it, it's taking too long to respond, it's syncing really slowly, scenarios like that, reach out to me because I love diving into these things and helping people optimize, and ultimately it we learn a ton about the way GraphNode thinks and all of that. So if you guys run into anything, let me know, and I'm happy to dig in. But other than that, I think we may be able to reclaim some time here.
Thank you so much, Derek. That's awesome. We appreciate that overview. And I really appreciate you stepping in last minute to help out. So thanks. yeah, if anyone has any questions, feel free to drop them in chat, or you can obviously come off of mute. But yeah, that was really good. Or if anyone else has anything else they want to talk about, these are office hours, so we want to keep it open. So everyone here is going to be kind of hanging out for the next 20 minutes or so. So yeah, feel free to speak up or type whatever you need in chat, and we'll help you out.
It's Martin from Pinex. It's not super related to builders office hours, but we launched today our blog, and we feature a bunch of stuff there for people to learn about files and substreams. There are a couple of summaries about demos that we have recorded with developers. And just wanted to share that. I can share that in the link to the blog in the chat as well. And we also have Daniel Keys, our CEO, on the call, if he wants to say a couple of things. He wrote a pretty nice Hello World article, which I'm going to share in a bit.
Hey, thanks, Martin. Thank you for the chance to speak. And shout out to the team. So we just, as Martin mentioned, we just launched our new blog. The blog is really for all builders in the Web3 space, and in particular for sharing the knowledge that the Pinex team is growing in the realm of Firehose, substreams, and the graph. So we're proud to have recently joined as core devs with the graph, and we're really focused on operating the Firehose substream stack and helping to scale that. And a big part of that is helping to arm all the developers and indexers in the ecosystem with knowledge and resources so that they can run that stack themselves. Check out the blog. We got a few posts up now. My little intro post you can find there, as well as a few posts around, putting some more long form written content around some of the Substream Unleashed videos we've been putting out there. So the goal here is, a place to bring together some high level general content on Firehose, substreams of the graph, and some very practical ways on how you can leverage this technology and use it in the apps that you're building.
Thank you so much, Daniel. That's really awesome. Really exciting news, and I'm really excited to keep watching the blog. That sounds really awesome. Appreciate everything you guys do. Like, Pinex has been a great help with these office hours, especially, and just in general, like all the stuff with Firehose and substreams is just really great. So thank you.
Yeah, thank you, and really shout out to the team. I'll call out. So we actually hired a few community members that you guys may be familiar with. So shout out to Polly B, Wisdom, and Ujwal, who are helping us write posts here. And we've also got Catherine and Kevin on the Pinex team who've been heavily involved in getting this blog up and running. And again, only a few posts up now, but we've got a whole backlog of content lined up. And if you should expect to see at least one post a week going up there. And so it will more and more over time.
Great. Thank you so much. Does anyone have any questions for the Pinex team or anything about the graph that they'd like to bring up? Okay. Well, thank you again, everyone. Feel free to hang out here. We're going to be hanging out for the next 15 minutes or so. But I appreciate everyone's time, and hope you guys have a good rest of the week. So thank you so much.